We call our devices the Nano DLD. We expect that this device will allow us to identify cancer in patients that still have no symptoms.
Healthy individuals don't allow us to care for them. Today we do sick care. We care for the sick. If we will be able to move a notch up and start questioning and start interrogating to predict what may happen, it would be one of the most interesting new ways to look at healthcare.
This technology is in its very early stages. The way we envision it will work is patient goes to the doctor has this device, takes a sample, explores the presence of specific types of what is called biomarkers that telltale of the cancer that we are trying to detect.
Pathology has rendered diagnosis mostly based on analysis of tissues, but we have been moving to non-invasive procedures. So we call that the liquid biopsy. We believe that it's a big part of the future, not only of diagnosis, but of healthcare.
Exosome detection in liquid biopsy is a frontier that we are contributing with our innovation by trying to detect those exosomes in a fast and cheap way. Exosomes are little vesicles of the order of 20 to 100 nanometers, which is the size that our devices can handle. They are very, very small, 100,000 times smaller than the diameter of a human hair.
All the processes that you'd have to do to analyze a disease and get a diagnosis, in theory you could shrink that down to a microchip and do the same analysis that you would have to do with a whole lab in a hospital or a special company. Do it right on chip.
A pachinko machine is a machine in which you throw particles and they bounce randomly. In a nanopillar array, rather than 50% to the right, 50% to the left, they are big to go in a direction. So they will be bumping, but more often than not, the bigger particles will bump and go the angle that we want them to go.
Being able to separate particles in this size range means that we can target a lot of things that cause disease. So exosomes are one thing. They're a good marker for a lot of different cancers. And then there are other things like viruses and protein complexes that also play a really important role in not just disease, but healthy states as well.
If we can identify not only one molecule or one protein or one DNA, but if we can start looking at the disease at the multidimensional level, if we can get inside of the disease and look at from inside out, we may have the opportunity of doing something very different.